A greeting to supervisor and examiner. I'm Jasmine Dongwang with metric number 79628. Today, I'll be presenting the final year project 1 with the title Paw Detect Breed Identifier for Dogs. Nowadays, people are increasingly falling in love with pets, and dogs are the most popular choice, as noted by Holland in 2019. However, many dogs have the same appearance but differ in breeds and characteristics. For instance, the Samoyed and Japanese Spitz look almost the same but are distinct breeds. For pet owners, understanding the specific breed of the dog is important to ensure the proper care. Unfortunately, relying on visual inspection is time-consuming and the results may not be accurate. Therefore, breed identification apps can assist owners in knowing the breed-specific information such as nutritional preferences and care routines, which empowering pet owners to give their dogs the best possible care. The first research questions of this project is how to automate the breed identification task. These questions focus on leveraging technology to simplify and streamline the process of identifying dog breeds. Second question is, can we identify breed based on visual information extracted from still image? Well, the goal is to determine if we can use computer vision techniques to classify breeds accurately based on images. Now, moving on to the objectives of this project. First, to build an Android app that can identify local dog breeds. And second, to implement the image-based classifier function into the app. Three existing apps are compared, which is Dog Breed Identifier, Dog Breed Scanner Auto-Eden, and AI-based Dog Breed Identifier. These three apps can identify the breeds by take a live photo or use existing image, but only AI-based Dog Breed Identifier can let the users to identify the breeds by using video. While the three apps show the identification history to the user and provide both general and breed-specific information. AI-based dog breed identifier have some more features, which is create pet dog profile, can let the user share their pets in the community, and provide tips for dog care. Several technology are used in this project. First is Teachable Machine. Teachable Machine is a practical and accessible tool for integrating machine learning into the proposed Paw Detect app. Its simple interface allows developers to train machine learning models without coding. Besides, it can directly export models for Android applications and is accessible from any device with a browser. Java is used for developing the Paw Detect apps. As a film developer with a background in Java, familiarity with its syntax and concepts can provide an advantages. Besides, Java has a strong community support and is officially supported by Android Studio. Its extensive library can save the development time and effort. Firebase real-time database is a compelling choice for the Paw Detect apps because it's built-in security rules to protect the data. Besides, it has the smooth interaction with other Firebase services such as Authenticator and Analytics, and it can work offline. For this project, Figma is used to design user interface that is simple and user-friendly. Android Studio is used to develop the Paw Detect app. Three existing apps, which is Dog Breed Identifier, Dog Breed Scanner Auto-Eden, and AI-based Dog Breed Identifier, is compared in this project. First, Dog Breed Identifier have direct button for users to know the breed details on the result page. It also provides general exercise and training tips to the users. The page is easy to use. But the drawbacks of this app is the information of the dog breeds is less specific. Second is dog breed scanner auto-ident. The strengths of these apps is the interface design is simple and is easy to use. But the drawbacks of these apps is the button no more on Wikipedia on the result page does not work, and it only provides general information of the dog breeds such as height, weight, and lifespan. Third is AI-based dog breed identifier. This app is suitable for the first-time dog lovers to find their suitable dogs since it provides a quiz. And it helps users to create individual profile for their pet dogs and provide information about dog moods and how to calm the dog. The downside of this app is the dog's information is too long and a burden to read since it is provided in paragraphs but not in point form. Three popular frameworks and libraries are compared in this project, which is Teachable Machine, TensorFlow Lite, and OpenCV. First, Teachable Machine is a beginner-friendly tool that requires no coding skills, making it highly accessible to users without a technical background. Then, it can directly export for Android apps. It's also browser-based, so users can access it from any device with an internet connection. But the drawbacks is it is not suitable for building complex models and requires an internet connection for both training and deployment. Next is TensorFlow Lite, which is an optimized framework for mobile and embedded devices. It offers extensive community support and documentation, which making it easier to learn and implement for developers. Then, it also allows for customization of models and deployment on various platforms. But it has a steeper learning curve compared to Teachable Machine and requires knowledge of machine learning and Python programming, which could be a barrier for beginners. Next, OpenCV. This library is known for its cross-platform compatibility and extensive functions for image processing and computer vision. It also benefits from a large community of developers and comprehensive documentation, which making it a reliable choice for many computer vision tasks. On the downside, OpenCV requires more programming efforts, and it is not suitable for creating complex neural networks. To summarize it, Teachable Machine is perfect for simple and quick setups, but its lack of support for complex models. TensorFlow Lite is powerful and flexible, but it requires a solid understanding of machine learning. OpenCV is great for image processing and visual-related tasks, but needs significant programming effort and is not ideal for neural networks. Let me walk you through the workflow of Paw Detect, which consists of 5 main steps. First is user. The process begins with the user inputting an image of a dog into the app. Then, the app sends the image for further processing. Teachable Machine's model will analyze the image and predicts the breed. The result is then paired with the relevant data in the database. Next, the app retrieves the breed-specific information stored in the Firebase, such as care tips and feeding guidelines. And finally, the results are displayed to the user in a clear and easy-to-understand format. This workflow ensures a seamless experience for users, from uploading an image to receiving accurate and detailed breed information. This is the flowchart for the breed identification process in the Paw Detect app. First, the user starts on the main screen and then navigates to the scan page. At this page, the system will check if the input is an image or not. If no, Users can choose to go to the other pages such as settings or search, or user can choose to exit the app. If user choose to identify the dog breed, they have to choose the input methods, either capturing a new photo or uploading an existing photo from the gallery. The input image will be processing to identify the dog breed, and finally, the app displays the breed identification results with the relevant breed-specific information. This flowchart outlines a clear user journey and ensuring a smooth experience throughout the breed identification process. This flowchart shows the process of creating a pet dog profile in the PodDetect app. The user begins the process by tapping the Get Started button at the dog profile interface. The first step is entering the basic information about the dog, such as its name, age, and breed. Next, the user provides health-related information such as allergies or any medical conditions. After health information, the user specifies the dog's dietary preference, including the diet. The user then inputs information about the dog's daily activity and exercise. Finally, the profile is completed by pressing the Submit button and save all the information and create the dog's profile. This approach ensures that all essential details are collected and organized. Two existing applications are involved to test the accuracy of identifying the local dog breeds. These two apps are Dog Breed Identification and Dog Identifier. While a picture of Japanese Chin has been used to test both the apps in 3 times, and both apps are misidentified. And the results show that both two apps have a problem in correctly identifying the local dog breeds. Here is the bar chart that shows the results of breed detection for Japanese Chin. Dog breed identification correctly identifying the breeds once but made 2 incorrect predictions. The dog identifier apps fail to correctly identify the Japanese Chin, with all 3 chances being incorrect. This indicates that the coverage of the local dog breeds in the database is limited. In this project, I took 8 days to complete the brief proposal and 21 days to complete the full project proposals. For Chapter 1, I took 5 days to enhance the full proposal and submit it. For the Chapter 2, literature review is done for the existing apps, programming language, databases, frameworks and libraries, and the other tools used. So I took 16 days to complete the Chapter 2. For Chapter 3, I used 17 days to complete it. A questionnaire is prepared and conducted, and the data is analysis, and the user interface design for the PodDetect app is done. In conclusion, the proposed PodDetect apps aims to help users understand and raise awareness about the local dog breeds by upload or scan the image. Image identification and processing can help users get the information quickly, while users can learn about the breed-specific details such as lifespan and exercise recommendations. Here is the list of references. A total of 13 references is used in this project. That's all from me. Thank you for listening.